Why D is very, very good for me. What is a wonk? Well, there are three different definitions. A student who spends much time studying and has little or no social life, a grind. A stupid, boring, or unattractive person. And number three, a person who studies a subject or issue in an excessively assiduous and thorough manner like a policy wonk. I'll let you decide which one applies by the time we're done. But it's interesting that wonk is no backwards. So I'm going to tell you a little bit about something I know about. What I would like to do is talk about how we got to where we're at. And so let's take a look at where we're at, language-wise. I'm going to go to tob.com right now. Okay, so here's where we're at. The May TOB index, Java's number 1, C is number 2, and C++ is number 3. It's pretty much, it's those three on the top all the time. Have you noticed? I don't know how many of you keep track of that. And I think we can kind of guess why languages are where they are. Any surprises here? I think number 13 is a big surprise, don't you? I probably shouldn't. I better be professional. I'm not going to say anything about Perl. I just did, didn't I? Yeah, that's too bad. What is this last thing on the bottom? ABAP. Does anybody know what that is? No. Okay. It's in the top 20. What is it? Oh, okay. All right. Well, of course, to see D, we have to go down to number 30. And that's where we're at. We used to be higher, but they changed their ranking algorithm years ago. Walter told us about that. That's okay. We're still ahead of Scala and Lua and Erlang and F# and Groovy and a number of other things. But if you look down here, you can see what languages have prevailed over the years. C holds a pretty top spot, doesn't it? Java has done fairly well since 2000. C++ has done quite well for a long time. So as you can see, C++ has indeed been with us for a long time. All right, how did we get there? Well, one of the advantages of being older than Walter is, I'm quite a bit older than Walter. He's old enough to be my very younger brother. Is I have some perspective. And so I wanted to share with you my perspective on how we got here, and especially with C++. I'm doing this in the spirit of something that may not be familiar with you, to you. I don't know if all of you are familiar with a show called Saturday Night Live. I don't watch it anymore, but I watched it 30 years ago. And they had Garrett Morris play a character named Chico Escuela, who is a baseball player imported from a Central American country. He didn't speak English very well, but boy, could he play baseball. And whenever they would interview him, about all he could say was, "Baseball been very, very good to me." And then they would ask him more questions, and he would say, "Baseball been very, very good to me." And so, to give credit where it's due, I just want to say C++ has been very, very good to me. I have been using it for a long time. Here's my shameless slide. These are my books, and so I'll just get past these right away. But perhaps you've heard of Thinking in C++. I was a co-author with Bruce Eckel on that. It's a little out of date now. I'd love to update it, but I'm really thinking of thinking in D instead, and I'm taking a sabbatical next spring. And I'm going to be working on a book on computation theory, but then I'm also going to start working on thinking in D. And Bruce Eckel said, yes, I may use the term. So I thought that was nice. Okay, so credit where credit is due. C++ was adopted organically over time. Now, what do I mean by that? There is no single company that owns and hypes it, right? C++ just kind of grew the same way C did. And so people started using it because they wanted to. No hype at any time. And in my experience, C++ is what took object-oriented programming to the masses. Because the C compilers were everywhere, and C++ was, in the beginning, a front end to a C compiler, and so people could use C++. What I would like you to do is I want you to go to this URL. Would you please go to padlet.com right now on your device, because this is how you're going to contribute to the discussion. Chuck_Allison/CPP_good. I'm going to leave that up just for a second. I'd like those of you with devices or computers to go and log on here, because you're going to contribute. So again, that's padlet.com/Chuck_Allison/CPP_good. And now I'm going to go there. Okay, tell me what you like about C++. I'll start. It's fast. What did we get? Okay, you don't like C++ at all? You've never used it? I mean, oh, here we go. Easy C interoperability. I've never liked C++, thank you. Okay, you might as well be honest. Although it says C++ good, what do you like about C++? So, okay, I'm going to get rid of you, but that's all right. Active community, true. Powerful, comprehensive, oh, that's for sure. Nothing. Okay, again, you're on the wrong slide here. All right. Okay, native compiled code. All right, that's about it, huh? C source compatibility. A lot of people don't like that about C++. That's one of the things that made Walter do D. Am I right, Walter? Yes, indeed. Because it was the C compatibility that made C++ the monster that it is. But good point. Makes D look good. Okay, there we go. Okay, I like that. Libraries, being taught to many new students. Metaprogramming, undefined behavior. STL is good. Hey, was STL innovative or what? I mean, you got to admit, I was there when Alex Stepanoff brought it to the C++ Standards Committee, first in the fall of '93 and then in the spring of '94. Over. Did somebody go to another page? I don't know what that means. Okay, boost. Oh, very good, very good. Improving language. Well, they are improving it. Consistency with a wink and a smile. Okay, good. Well, thank you. Now, you're going to go back to Padlet 2 more times, just be aware of that. Okay, so there are reasons to like C++. Now, I want to tell you how C++ progressed and how Java came to be so popular, and then how D came to be around. So this presentation is just my 2 cents, which, of course, it's called your 2 cents because basically it's worthless. But you're here listening anyway. Okay, a little prehistory, and this is just me. I began, like some people, with Fortran in 1975, so that was my first, well, it wasn't my first programming experience. My first programming experience was on a Wang calculator in 1970. But that, was basically a programmable calculator with 77 possible instructions. That is, you can only write a program up to 77 lines. And you did it on a single punch card with a little stylus, and you punched them out by hand. Of course, I started professionally with Fortran punch cards. I caught on to C in 1984 with a very nice compiler called the Mark Williams C compiler. Walter, did you ever hear that? Mark Williams C? Yeah? That was an excellent compiler. And then along came this thing called Datalite C. Boy, was it fast, and boy, did it generate lean code. Does anybody know who the developer of Datalite C was? It was Walter. Walter created Datalite C. He's got this thing about compilers. Don't ask me why. Okay, well, in 1989 is when I jumped on the C++ bandwagon. I was an early adopter of Zortex C++, which was the first full standalone native compiler in C++ for MS-DOS. Do you all know who wrote Zortex C++? Walter, indeed. I wrote 5 chapters of the original releases of Turbo C++ and Borland C++ back during that time. Yes, if I were to go back and look at that, I would not recommend it to you. Those were early days. But hey, at least I was involved. And then I had the opportunity of joining the C++ Standards Committee, and this is where I really learned how things work when a language is done by consensus through worldwide entities instead of being sponsored by a single company. It takes time. The first technical meeting, I was there, March 1991 in Nashua, New Hampshire. And I spent 10 active years on the C++ Standards Committee. I got to know very many people very well, including, who's the first picture of? Bjarne Stroustrup, the inventor, designer, and original implementer of C++. How many people know who the guy in the second picture is? Anybody know? Don't say it out loud. Must be Walter. Yeah, you've changed, how you've changed over the years. No, well, let me just tell you, if Bjarne Stroustrup is Batman, Andrew Koenig is Robin in the C++ world, and there's no doubt about it. It was the Bjarne and Andy show for a long, long time. Anyway, it was a great experience, and I actually designed and implemented the bitset part of the standard library. Actually, I proposed 2 classes, bitset and bitstring, so we can have a bit vector that grows and shrinks and that kind of thing. But what did they do? They said, well, wait a minute, they did accept it into the language, but then STL came along. And they said, well, why don't we just make it a specialization of vector? And so thus was born Vector Bool. I do not take credit for Vector Bool, because that wasn't my idea. And so finally we fixed that problem. Jeremy Seek took my code and boostified it, and now on Boost you can get dynamic bitset. And that's what I had in mind in the beginning. So don't blame me for Vector Bool. Well, actually, they wouldn't have done Vector Bool if I hadn't done bitstring, but still, don't blame me. Okay, and then in 1991, I had this opportunity to meet a very interesting fellow named Walter Bright. And he totally forgot that he gave this talk, but I still have the paper copy. So C++ World, I took some pictures here for you. He gave a talk, Defensive Programming in C and C++. He was at Symantec at the time. They had bought the Zortex C++ compiler. And here's his second page. You can't read that. And you got my notes on there. Here's his topics. What is defensive programming? Programming under the assumption that anything can happen. Variables contain invalid values. Co-programmers are out to get you. Comments lie. Unspecified behavior is pathological, and correct behavior must be demonstrated. So I very, very much enjoyed that talk. Opened my eyes to quite a few things. So it was nice to meet him, and from 1992 to 2003, I was involved with the C++ Users Journal. Out of curiosity, out of show of hands, who used to read this journal? 1, 2, 3, 4, 5, 6, 7, 8. Is Andre here? Did you raise your hand?
Yeah, I wrote for it. So.
I know you wrote for it. Okay. Well, I had a column called Code Capsules that my first book came out of. And then I was a consulting editor for a while. And then I was the senior editor in the last 3 years. And yes, Walter Bright wrote for us. Andre Alexandrescu wrote for us. Interesting how these guys keep coming up. Well, Dr. Dobbs bought the C++ Users Journal, and it kind of went away in 2003. And I was actually talking to Walter at a software development conference. Now I've got to ask, how many remember SD, software development? Just Andre and Walter, nobody else? Just Andre and Walter and me. Oh, that's too bad. Anyway, and so we decided, we've got to do something so that we can have a continuing C++ experience like we've had with the journal. And so I'd like you to take a look at the names of the people on the advisory board. We finally came up with the C++ source as the name for it. This is still online. The last article that was written was 2008 by Scott Myers. But if you look at the advisory board, do you see any names you know? Call them out if you know them. Jim Copley, Neil Harrison. Neil Harrison is a professor here after 24 years at Bell Labs. Any other names you recognize? You just can't get rid of Walter Bright, for some reason. But Andrei Alexandrescu is also there, because the names are in alphabetical order. He comes in number 2. Bjarne, I've heard of him. Yep, I've heard of him. Matthew Wilson from Australia. Herb Sutter, right. Howard Hinnett, the originator of R-value references and move semantics, which we don't need in D, which is pretty nice. Okay, well, what I would like to do to segue us into D is I'm going to click here and I'm going to go to the C++ source. And I'm going to bring you one of the articles, editorials that I wrote, because I'm going to do a little quoting here. I'm talking about C++, and I'm finding it a little complex. Now, I really shouldn't say that because I've been involved at this point in C++ for, well, from 1989 to 2008, so that's 19 years, right? Well, Scott Myers was once asked what he disliked about C++, and here's what he said. I'd like to answer this question with complexity, complexity, complexity. Those are the 3 things. But naming the same thing 3 times is cheating, and still I think that C++'s greatest weakness is complexity. For almost every rule in C++, there are exceptions, and often there are exceptions to the exceptions. For example, const objects can't be modified unless you cast away their constness, in which case they can, unless they were originally defined to be const, in which case the attempted modifications yield undefined behavior. As another example, names in base classes are visible in derived classes unless the base class is instantiated from a template, in which case they're not, unless the derived class has employed a using declaration for them, in which case they are. Well, these things happen, and please don't get me wrong, C++ has been very, very good to me. And so I am not, well, I know it looks like I'm telling the truth, okay? That's what I'm doing. C++ did have C compatibility as a primary goal early on. And I actually asked Bjarne once, I asked him, what would you have done in designing a language if C compatibility were not an issue? And he says, that's not a fair question. I don't want to answer that. And he didn't. Because at the time, C compatibility was important not only to the survival of C++, but it was also important because of the legacy code base, as you know. Well, I just want to give you a little example of something that is a little frustrating, especially when we're teaching programming. So here's a little class called Box. It's a template class. It's very simple. All it does is hold a value, and I've got a constructor here that will take a value of the template parameter type, and I'll just hold it at this point. So when we're teaching students how to use templates very early in their freshman year, we'll do simple things like this to start. And now, let's suppose we ask them to do a stream operator so we can print out what the value of the box object is holding. Well, you know what they're going to do? They're going to say, okay, fine. I'm going to do what I do with other classes. I'm going to introduce an output operator as a friend in the class. And as is my habit, their habit, I'm speaking for the students, I will define the body of it outside of the class. Nothing wrong with that. So you know that this is what you do with non-template classes, if you want to. And you would think that this also works for template classes. But there's a minor problem here. And we get an error. Warning. Friend declaration declares a non-template function. Okay, and that's true, because the friend declaration says I'm a function defined elsewhere. the friend declaration just says, I'm giving you access to what's inside the class, the box class. And yet I'm using a template parameter as the second argument, the second parameter in the output operator. Well, the problem is I can't do that because this is not a template. And it actually gives you a little hint of what to do. And this is actually from GNU. It gives you a very nice output message. You don't typically get this nice message with other compilers. It says you need to add bracket bracket after the function name. Well, now that's interesting. So here is the way you correct that. What you have to do is you have to forward declare the box class so that it exists. And then you can do a forward declaration of the output operator as a template function. And then when you go inside, notice that we have 4 left angle brackets and 1 right angle bracket in the friend declaration for the output operator. And that's because you need to use the 2 brackets there to show that this is a function template. And now it works. Isn't that great? And now I can define its body outside. Our freshmen found that a little confusing. Now, of course, there's a workaround. All you have to do is do it Java style and define the body right inside the class and everything just works. But that function is not a template function. For every instantiation of the class, you get a different non-template function. Very interesting. Okay, well, this is at the point where I brought up a quote from Dijkstra. I absolutely fail to see how we can keep our growing programs firmly within our intellectual grip when by its sheer baroqueness, the programming language, our basic tool, mind you, already escapes our intellectual control. So down here in reference 6, I say, no, it's not reference 6, it's reference 7. I see some promise in Walter Bright's deprogramming language. It's not a C++ replacement. It is for me, though. But it makes the C++ developer feel at home while providing support for systems programming, exported templates, on and on and on. All right, well, that's what happened in 2008. And actually, that was 2005 when that article was. All right, so where are we now? Now I want to, at the end here, before I get into some code, talk about software development. I mentioned this conference. Having been there, I watched as Java emerged. C++ was the language to know and the language to learn. I had a lot invested in it. And then I noticed that Java came along. And as I observed people speaking about Java at the Software Development Conference, it was always as a replacement for C++. In other words, C++ is too hard to use. Let's use Java. It has garbage collection. You don't have to worry about memory management. Of course, we've already heard about that, and we shouldn't manage memory anyway, right? Of course, the portability of the VM was very important, and also the fact that the internet was just, or the web was just becoming important. But the biggest thing that drove people crazy was they had trouble with pointers. Now, I'll have to admit, our freshmen have trouble with pointers too. Now, I have 4 students here. Hello, Russell. Did you guys ever have, they're on the front row. Did you ever have problems with pointers? Okay, Andrew says yes. Travis says yeah. Eric doesn't want to admit it, and Russell says, a little bit. Did any of you ever have problems with pointers? Only a few of you. Okay, all right. Well, everybody else is lying. That's right. Yeah, okay. I should say. Well, to me, this is one reason why Java succeeded, although it was a confluence of other events as well. It was a perfect timing. So in 2004 at the Software Development Conference, now look at the speakers again. This time I've put bullets by the ones that we're talking about here. Walter Bright gave his first presentation on D. Now, Walter, do you remember the medium that you used at that presentation? I was there.
Everyone complained about it.
Everyone complained about it. May I share with them what the medium was?
Yeah.
an overhead projector with blank transparencies, which he wrote on with a pen. But he since went back and compiled a PDF for that, and this is what that is. Now, what I'd like to do is I'd like to go down to near the end here, and I have a couple of things highlighted that I want to just share with you as Walter was making his case for the D language. They're highlighted in yellow, so here we go. There's no need for multiple warning levels in D, a D puzzle book, a lint program. Well, that's changed. A bug of the month, or a world's leading expert on preprocessor token concatenation. There's no need to convert C code to D. New functionality can be written in D and linked into the existing C object core. D locks down many undefined or implementation-defined behaviors of C and C++, thereby making code more predictable and portable. And he lists what some of those are. Of course, we take a lot of those for granted now. And then finally, D starts with ensuring that no variables or object members get left uninitialized. Next, and most important, are designed by contract and unit testing. The answer isn't to force programmers to write test and verification code. It's to make it easy to do it and manage it. Easy enough to tip the balance and make adding such as much a matter of course as adding comments, with the difference that the test and verified code actually run. Decompilers can potentially generate better code than equivalent C, C++ code because. Okay, well, we'll end right there. So I just wanted to share with you at this point that over the years, we've had C++ adopted organically. Everybody loved it. No one was forced to use it. They used it because it worked for them. But Java also worked for many people too. But for those of us for whom Java was not the solution, we still held on to C++. But this idea of C compatibility and growing complexity left us wanting. And so that is where D comes in. So now I'd like you to go back to Padlet, if you would, because what I'm going to do is spend the rest of my time talking about why D is very, very good for me. I want you to take a moment and tell me why D is very good for you. So Padlet.com, Chuck_Allison, D_good. Let's go there. Wow, we're already there. That's great. Now let me make this bigger. Not PHP, okay. That's something. Okay, I know who said this. It feels like taking a bath. Yes, it's clean. Best modeling power in town. Understandable templates. Oh, isn't the syntax for templates delightful in D? Yeah. Fast compiler, which one? No, I didn't mean to bring that. Python that compiles, CTFE, slices, universal calling syntax, unit test, range, oh yes, easy to add inline assembler, ranges and algorithms, easy, powerful. Boy, this is going fast. What's that? Well, I feel sorry for those that can't see all these things that are coming up here. Yo, dog, I heard you like code, so I wrote code that writes code so you can, yeah, okay. Got rid of that one, huh? Yeah. That kind of reminds me of the famous functional programming mantra. Why write a function when you can write a function that generates a function? Yeah, sure. Okay. Scriptable. Yes, very good. Unit test next to your code. Alrighty, I think we're converging here to consensus. Okay. Well, all right, you pretty much covered almost everything I've got, so good. That'll make the rest of this a little easier. Okay. Well, allow me to tell you why D is very, very good for me. I, like all of you developers, love the following. It's not Java. It compiles to native code. It's not C#. It has garbage collection, but I don't have to use it. The module system, to me, it feels just like Python, which was the best module system I'd ever known. And it's just so easy to use. Slices, associative arrays, static if, Of course, we've already mentioned universal function call syntax, compile time function evaluation. What about mixins? They have their issues, but boy, can you do great stuff with mixins. Then unit test, contract programming. Let me just show you some examples here. Here's an example of an associative array. I just like clean things like this. So what I have here on line 5, can you see that back there, Walter? Yes. Okay. Sorry for using you as a guinea pig, but this is going to be a cross-reference program. I'm going to give it the Gettysburg Address. That's what I'm reading in from standard input. And it's going to list alphabetically, and at this point, just for simplicity, I did not separate uppercase and lowercase. And it will tell you what line the word appears on, all of the lines, and how many times on that line it occurs. So, for example, let me just scroll down a little bit. You can see on line 28 that the word we, capitalized, occurs twice on line 5. And occurs on many lines, twice on line 5 as well. I find this an incredibly readable and concise program to get the job done. I have an associative array here that associates a string with another associative array, which associates an int with an int, the line number with the occurrence count. And so it's easy just to read all the words in line by line, split them, and I can just add to my associative array on line 8 what line number it is in. And of course, I'm adding 1 because I want the line numbers to start at 1 and not 0. And it automatically creates it, as you know, and puts it in there. And then it's really easy to print it out. So I, like all of you, really appreciate associative arrays. How about UFCS? It's so nice that universal function call syntax gives us the nice pipelining ability to say, do this and take that result and pass it on to this and take that result and pass it on to this. So line 12 is how a functional programmer would have to do what I have on lines 5 through 9, which I find much more readable. So we'll take this set of values and we will change them all to multiplying them by 10, then we'll divide them by 3, and then we will filter out those that are odd. We'll just keep those that are even, and then we will pass the result to right line. And so we get that. Good stuff. Other cool language features. Slices, of course. So I've got just short little examples here that I give to students. Here's one that will test to see if a string is a palindrome. So all I have to do is check to see if the first and last characters are the same. And if they are, I will go into the next and the next and the next and the next. By using slices, all I do is get a different view. I don't get a copy. And so it's a very efficient use of memory. And that does the job. Comment?
Yeah, then Unicode happens.
Excuse me?
Then Unicode happens.
Oh, yes, Unicode. Okay, well, I'm just trying to show slices here. Okay, array-wise operations. So I have a little function to create to calculate the dot product of two arrays. And so I will create a result which is the same length as each of those. So I'm on lines 8 and 9 now. And then I will use the bracket operators to do the component by component wise multiplication of elements in the two different vectors. And then I'll call reduce here to add them all up, and that returns the dot product. And then in the main, you can see how those things are done. So array-wise operations, very nice. I also teach a class in MATLAB, so this is a little bit of something that you can do in D that's similar to that. Lazy evaluation. This is another privilege I have of being a senior person. Hopefully I won't have any senior moments for the rest of the talk here, but there's this thing called Jensen's device. Has anyone ever heard of Jensen's device? Okay, well, who cares? Oh, okay, fine. It's something that came with Algol many years ago, But basically, it's kind of a pass by name in a very interesting way. So just to show you what it does, look at line 17. See, I have this vector, this array with the numbers 1, 2, and 3. Now I have this function sum, and I'm going to pass the actual index variable because it needs to be used locally in sum. And so what's happening is I'm passing I by reference, and I'm passing the expression in the fourth parameter of my call to write line as a lazy expression that returns a real. And this allows me to call my sum function many different ways, and yet I'm computing the sum of different computations. So the first time I call it, I'm just computing the sum of the elements. The next time I'm computing the sum of the squares of the elements, then the sum of the cubes, then the sum of each element times its index number, etc., etc. So it's a very interesting feature, and I get the answers that I would expect. So there's the sum of the elements, the sum of the squares, the sum of the cubes. Interesting. Obviously not so interesting that you wanted to say something about it. Let's talk about using delegates as decorators. In line 4 there, I have a function called incalls, and all it does is it wraps a function in another function, a delegate, and will keep track of how many times that function is called. And every time you call this wrapper, it will return when you actually call it. It will return how many times it has been called. So let's take a look at this. You can see what I do is I get the function as an alias parameter, an alias template parameter, and the type of what it is. I'm assuming the function takes something of type T, and then I'm going to calculate it, but then at the same time I'm going to return what the count is. And so the purpose of this is just to see how many times the function was called.
You could have used traits and you didn't need the uppercase T, because you
could have used traits?
Yeah.
Right.
Ask what the return type of the alias F.
Oh, exactly. Oh, yes, right. Matter of fact, I have an example coming up later that does that. Right, yeah.
I think you don't need to delegate here. You could just call F from side uncles and count it in scope exit, and it would work the same.
Ah, there you go. Okay, so could use scope exit. Right. Good. Anyway, I like delegates because I can use them as wrappers, and of course that's what we do in functional programming. Here's a concept that I appreciate from Python. Of course, it's not a new concept with them, and that's the idea of a bound method. So you can connect as a delegate an object and a particular method to call on that object, and use that entity and pass it into some other service as a callback. So I just have this simple function called service. It wants something that it can call, and it's going to call it and return its value. Well, how do I do that? Well, I'll just take an instance of some object that has a method on it. And so in line 9, I'm creating a class A with fun. And then in line 10 is where I'm binding the object to the method. So this is called a bound method. And now I have this thing, which is a method that will be called on behalf of some object later when I use it, and I pass it to service in line 11. So another very nice feature. And then, of course, shared is nice. It does actually work sometimes, and you can actually understand it. But here I'm also showing atomic op. What I'm doing here is I'm just spawning a couple of threads that will print out either dessert topping or floor wax. Where does that come from? Oh, who cares? Saturday Night Live. Okay. It's a dessert topping and a floor wax. Okay. Anyway, every time I print something out, I want to be able to print out which element it was. Like, is this number 1, number 2, number 3? And so I have to increment a counter, so I have this shared thing locally or globally here at the module level. And then I can use the atomic op in the function, and it will not, and then it'll be thread safe. All right, so things we like in the language. Let's talk about the library. Python, very nice language, is called, they say that Python comes with batteries included because of its wonderful library, and it is a very wonderful library. Well, I would like to mention that D comes with the nuclear reactor included. Because its library is still growing, of course, and perhaps there aren't quite as many components as Python, because Python has at least I was going to say a 10-year head start. It's about true, I think. Nonetheless, the powerful things in the D standard library in Phobos. I love scoped. Here, just for fun, I'm going to do the curiously recurring template pattern where I can have a template, which I have in the form of counted here. This template has a static counter and a function to get that count, which will count how many objects of a particular type were instantiated. So it has a default constructor that increments and a destructor that decrements the count. And then I'm creating in line 13 a class that will automatically use this functionality that it derives from my template, so that this particular class will always be, I can always find out how many objects there are at the moment. And of course, it's curious because in line 13, I'm defining a class by inheriting from my template which instantiates the class. Perhaps you've all seen this idea before. So to some people, it looks a little circular. Anyway, what I want to do is I want to be able to show how many elements there are at any time. And so in the beginning, when I print out get count on line 16, there aren't any. Now I'm going to create one on line 18. When I print it out, I've got one. But at the end of this scope, I want it to go away. So I had to use scoped to make sure that the destructor would be called. So I have my option to get deterministic destruction very easily in D. Partial function evaluation, also known as currying. Being a functional programming guy, I kind of like it. Unfortunately, at the moment, you can only supply one parameter at a time, one argument at a time. For those of us functional programmers, we want to be able to, suppose I have a function that takes 4 arguments. Well, I might want to be able to pass 2 and then get back a delegate waiting for the last 2. And I can't do that right now with partial. I want to be able to do that. But I can do them one at a time. So in line 6, I'm going to say CF is a delegate that is holding on to the first parameter for F. F takes 3 parameters, which is going to be a 1. And now I'm going to call it and give it the last 2 in line 7. So of course, when I plug in 1, 2, 3 to my simple function, I get 7. But what I can do now is I can take that CF variable, which has the first variable 1 from line 6, and I can put that into its own separate entity. I'll call it CF2. And now, and I'm going to give it the second argument, and then finally in line 10, I'll give it the third argument. So we functional programmers appreciate that. We would appreciate it even more if partial would take an arbitrary number of arguments so that we can not be hamstrung by that. Discriminated unions with algebraic. Discriminated union is something that I'm used to using. I love it. It's just a variant which is bounded, which is set. You just tell it what types it can have. And so here my, my type 1, 2 can hold either an int or a tuple of 2 ints. So now I can have an array of those things, and I can add something that has 1 int or something that has a tuple of 2 ints. And I can just use that and print it out. And so how do I actually do computation on that? I use visit in line 15. So visit is a method of algebraic, and it just takes the delegates to match, just like receive does with message passing. And so if the current element happens to be an int, it'll just return it. If it happens to be a tuple, it'll return its product, so that when my sum function will sum all of these things up, it actually will give the sum of all the elements, except if they were tuples, it will add the product into the running sum. So algebraic, very nice feature. Memo-wise. Well, you know, I'm a mathematician and I'm a professor, so I am obliged to use Fibonacci numbers. You have to do that. And so I do it. And so the first function there, line 3, fib, it just does it by the usual recursive method. Now the second one uses memoize, which, as you know, what it does is it'll keep an association of all previous arguments that have been called, so that instead of reevaluating it, it'll just look it up in its cache and return the value that it previously did. And then just for fun, because you're going to see some timing results here, I also did a tail recursive version without memoize, and then the traditional iterative version. And I timed all of these things. And so in line 53, the bare bones version used, how many is that? 80 million clock ticks. The memoized version cut that down to 26,000 for me. Of course, if I made it tail recursive, it's even better, and the recursive or the iterative version is the best. Memoize is very handy when you need it. Fibers. Now I realize that fibers were created and are typically used in the context of threading. But for me, fibers are also generators, a form of coroutine, which I use all the time in Python. And so I don't have to use threads to use fibers. So here what I'm going to do is I'm going to create an infinite Fibonacci stream. It's going to just, every time you call it, it's going to yield the next Fibonacci number for you. And I actually have added a function here so that you can stop it whenever you want to, and actually have the fiber destroyed or terminated. So all I have to do is do what I would normally do with a Fibonacci computation, but I will just yield it every time. And so here I'm just going to print out all of the Fibonacci numbers that are less than 100. And so I'll print out 0, 1, 1 all the way through 89. And when I call stop on the fiber, I can assert that my fiber has been terminated. But of course, you should be saying, well, now, Chuck, why are you using fibers for something this simple? Fibers really aren't necessary to use for a simple case like this. Why don't you use ranges instead? And I couldn't agree more. And so here I'm going to create an infinite Fibonacci stream, but I'm going to use ranges instead. It'll never be empty in this case because it's infinite. And I'll just hold on to the current number and compute the next one for next time in pop front. And so now I can do the same thing as I did before. I can print out all of the things that I want to do. So I'll just call pop front, and I will of course call front to get what I need, and then call pop front to advance. Now I want to just also show some of the other things that we functional programmers like. Until. So I can create this. I can use this range, and I'll say, give me everything until the current element is greater than 100, and this will do the same thing. It will give me all of the, are you saying no? Oh, you're not. Okay, I thought you were shaking your head no at me. So this will give me the same thing as my loop. But I happen to know that there are 12 of them, so another way is to just call take, and then I can get all of the things that I wanted as well. Okay. This will be our last Padlet exercise. Please go to padlet.com/Chuck_Allison/D_tools. And here I really would like your input, because this is the one area where I think it's been difficult for me to keep up. What are the nice tools and resources that we have? Well, obviously RDMD, love that. dlang.org is wonderful, the tutorials, the documentation, all of the information. Dub is a delight, package manager and builder. I just tried out vibe.d last week, and I must say that was a great way to do web apps. Now, how many have heard of Xamarin Studio on, okay, good. How many have heard of MonoD? Okay, it's the same thing. All right, so Xamarin Xamarin is a very nice IDE for D, by the way. I don't have time to show it to you. I was going to. And then also, we have, of course, the books. We have Andre's book, which I'm sure he'll update sometime soon. We have Ali's online book, and then we have Adam's D cookbook, which is delightful. Let's go to Padlet now and see what you're telling us. Okay, what are the nice tools we have? Now, I don't know what all of these are. What's DVM?
It's a version manager that allows you to switch between versions very quickly.
Oh, version manager.
Just a single command line, so you can actually have several of them installed on your computer and then just switch between them.
Very nice, very nice.
For compilers, so you can actually switch between, even if you have really old legacy D1 code, you can switch back to that.
Okay.
Hopefully you know.
Visual D is nice. The standard library. Emacs? Okay, that's a wonderful tool. I was kind of hoping to have more D-specific ones. LibD parse, GDC and LDC, MyBrain, and IRC. Okay, there you go. DFix, which we've heard about today. Now, I haven't heard of DUnit. What's that? Is that just like in-unit stuff? It's just a unit testing framework? Is that what that is? Okay, good. Walter and Andre, I totally agree. Thank you. Okay. Well, I think that's a great place to end because we've heard a lot about Walter and Andre. I just got rid of my presentation, and I have one last slide, so let me go there. What did you say?
Are Andre and Walter tools or resources?
Oh, are Andre tools or resources? That's a good question. What would you rather be? Yes. Okay, very good. All right. Well, so there you have it. That's just my 2 cents. Why D has worked for me. The timing was good. The losing of the C compatibility constraints was good. And of course, just the design was good. Now, I just wanted to mention that there's more to come. I have a student, Eric, who's been sitting here the whole time. He's giving the last talk in the conference, and I'd like to encourage you to be sure you're here for his 3:30 talk tomorrow. He's going to be talking about his experiences where he decided to switch to D in the middle of the semester when he was learning D in one of my other classes, to write his virtual machine with embedded assembler and then his compiler as well. And so he's going to show you all of his adventures and what a good experience that was. Thank you very much.